Hi, now we are discussing pyrolytic elimination. This is very interesting type of reaction. What happens here in this reaction? There are certain molecules like esters, not all esters, xanthates or amine oxides can undergo elimination at high temperature. So we have to take that compound, either ester or xanthate or amine oxide separately, and heat them at high temperature, obviously in a gaseous phase. What happens? Elimination takes place. Elimination means what? Two atoms or two group of atoms removed from the molecules to form a double bond, to form a pi bond. That reaction is called elimination reaction. So in elimination reaction, you are not using any other reagent. You are taking that molecule and heating it strongly to get the elimination product, and this is called pyrolytic elimination. Pyra means heat, so elimination taking place in presence of heat is a pyrolytic elimination. Again, during this process some bonds are broken and some bonds are formed, but that bonds are actually forming a cyclic transition state, and we know very well if cyclic transition state is formed, that reaction is called pericyclic reaction. So this is again important. Pyrolytic elimination or pericyclic reaction are concerted type reaction where bonds are formed and broken simultaneously through a cyclic transition state. Again, as I mentioned, we are taking only one compound, either ester or xanthate or amine oxide, and we are just heating it at high temperature. So the elimination is called intramolecular elimination. So within molecule elimination takes place. So this is also called EI reaction. EI stands for intramolecular elimination. Now we will discuss a few examples. So the first example is pyrolysis of acetate. So I am taking here ester. Acetate means what? Ester of acetic acid. So here when we replace hydrogen of acetic acid, so this portion is, if I replace R with H, that will be acetic acid. If H of the acetic acid is replaced with alkyl group, that becomes alkyl acetate. So we need alkyl acetate for this pyrolysis reaction. So you remember very well that this portion CH3COO up to this O is acetate portion, acetate part, and whatever group is attached to the oxygen, that is called alkyl group, where we are using alkyl group. So you focus, there are two parts. So alkyl group is what? You need such type of alkyl group, there must be a beta hydrogen. So at least two carbons should be there, and on second carbon means the carbon attached to the oxygen is the first carbon, and then the next is second, that is beta carbon must have at least one hydrogen for this reaction. So that is the condition of pyrolysis of acetate, pyrolysis of acetate ester. Now here I have shown the reaction. Now see, this is an alkyl group. As I mentioned, there must be beta hydrogen, so there must be minimum two carbons. So here I have shown two carbons, and on the second carbon, the first carbon is called alpha, second is beta, where the hydrogen is present. So this is called beta hydrogen. So in short, that hydrogen is moving to join with hydrogen with oxygen of the acetate part, and you have to put this bond between alpha and beta carbon, because in elimination reaction there is always formation of pi bond. So this pi bond is formed. That means this compound gives alkene, where minimum two carbons present, and the acetic acid, because this is acetate. Now if I want to mention here a cyclic transition state, so we will try that cyclic transition state so you can understand this reaction properly. So I'll take this molecule here, but I'll write here this molecule very different. So C double bond O and CH3, then CH2, CH. I need one H here and R. So you have to write this molecule in this fashion. Now what happened? You just see here. There is a bond formation between here. This bond is moved here in between alpha and beta. This bond is moving here. That means this bond is broken. This bond is broken. And this bond is moving here in between H and O. So this bond is formed. So as I mentioned earlier, you have to show that bonds by using a dotted line. So which bonds are broken? That bond you show by using a dotted line. Here this is a dotted line and H, then this bond is broken, this bond is broken. I'm using different colors, and CH3, one bond is still there, and see this bond is formed, this bond is broken, and this bond is formed. So if I draw which are the bonds which are being broken and bond which are being formed by using a dotted line, we get here cyclic transition state, and this cyclic transition state is now converted to the our alkene, means our product. So double bond between CH and R plus, and there is always formation of acetic acid, so O and H. So what is this? This is a cyclic transition state. So this is a cyclic transition state. That's why this is pericyclic reaction. You can take number of examples here. By using this reaction, actually what you are doing, you are dehydrating alcohol. You are dehydrating alcohol. So the alcohol is treated with acetic anhydride. That means acetylation is done, and after that it is converted to the acetate ester, and then acetate ester is converted to the alkene. That I can mention here. So I write here one example. You try to understand. I will make it more interesting. So when this ethyl alcohol is treated with acetic anhydride, so you know that the formula of acetic anhydride, and which is used for the acetylation reaction. So what you have to replace this hydrogen with this acetate. So you will get here ethyl acetate. So I write here CH3, CH2, O, this C double bond O, CH3. So this is ethyl acetate. When this is heated alone at high temperature around 500 degrees Celsius, at 500 degrees Celsius, what happened? This is alpha and beta. One hydrogen is joining here, so there will be two hydrogen, CH2 double bond CH2 plus OH, C double bond O, CH3. This is always there. Now if you look here, this is alcohol, ethyl alcohol. Alcohol is converted to the ethyl acetate, and finally if you look here, we are dehydrating. So this is nothing but the dehydration. So what is use of this reaction? Dehydration of alcohol. Alcohol can be converted to the alkene by using this reaction through the acetate intermediate, and this is all about pyrolysis of acetate. Thank you.